Components of forces. What this means is that we're going to take some sort of a vector, and in this case we're going to pick a vector fairly straightforward. It's going to be in quadrant 1. I'm going to say it's 30 degrees, and I'm going to say that it's a force vector at 250 newtons. So that means that you are pulling something in that direction there. Okay, so there's the direction it goes. We're trying to find the components. So our x shadow and our y shadow. This blue line is going to represent the x component, and this red line will represent the y component. Actually, this y is out here, but for the sake of our right triangle, we're going to create it over here and making a right triangle there. This red is actually pulling upward. This x is pulling to the right. So this, by putting it here, we can just slide it over, and it just makes a nice right triangle. So this will be my force in my y direction. This will be my force in my x direction. Those are the two things I'm going to find. And I'll start with my fx. It's a right triangle. I'm using trig. This is the adjacent side. So for my force in the x direction, I'm going to go cosine of theta is going to be adjacent over hypotenuse. So that means that cosine of this 30 degrees is going to be equal to my adjacent, which is fx, and my hypotenuse, which is 250. I'm going to solve that for fx, which means I'm going to cross multiply this. I'm going to get 250 cosine 30 degrees. So my fx will end up equaling positive, because it's to the right, 216.5 newtons. For my fy, it's going to be sine of theta is opposite over hypotenuse, because this is my opposite of 30. So that sine of theta is fy, which is my opposite side, over my 250, which is my hypotenuse side. And I guess I could put 30 degrees here instead of theta again, which I'll do. Cross multiply. So my fy is 250 sine 30 degrees. That's upward, which means that this is going to be positive. So I'm going to end up with 125 newtons. There's your two components. This is 216.5. This one or that one, whatever way you're looking at it, is 125. So that means we've broken this into the y and the x. So I can make a general equation now. Generally, for any component in the x direction, I can take whatever my original resultant vector is times the cosine of theta. So that's like my general x, and my general y is my resultant sine of theta. That's my general y, and I only can use y attached to sine and x attached to cos if my angle is off of the x-axis, between here and here. So basically you've got to be off of your x, the entire x. If our angle would have been here, we could have still done a component, but you would have ended up having to create right triangles, do this all again, and these two short forms don't work. So change your theta value to be off of x all the time. There you go.